All right, so again, we want to continue to find the zeros of a polynomial. So again, it all begins with our PRZ list. So looking at this, the last factor, right, plus or minus 1, plus or minus 3. And then 20, we have plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, plus or minus 20. All right, and so we unfortunately have a lot of fractions here. So if we divide everybody by 1, right, we get 1 and 3. If we divide by 2, we get 1/2 and 3/2. If we divide by 4, we get 1/4 and 3/4. If we divide by 5, I'm going to bring it down here, we get 1/5 and 3/5. If we divide by 10, we get 1/10 and 3/10. And then if we divide by 20, we get 1/20 and 3/20. Okay, so 2, 4, 6, 8, 10. 2, 4, 6, 8, 10. We have 24 possibilities. All right, and again, back in my day, I would just probably start with the 1 and the 3 and just try to start breaking the problem down from there, slowly whittling away at the polynomial. But we have technology, so let's take advantage of it. So there's the last example, so let me clear that out of there. So let me turn that off. We're now talking about 20x cubed plus 12x squared, so let me turn that one on and graph it. And I think my window, yeah, let me go and keep this window here. So we do in fact see the graph crossing. There's 1 and there's -1. So it does seem to be crossing. How about we say that's about a half? That seems to match what's on my list, all right, and what's on here. So let's shoot for a half. And then right there, it's kind of hard to see what it's doing. I don't know if it's at -1/2. So since we're not really clear there, how about we use that guy right there? And it does seem like x equals 1/2 is the culprit. So we're going to basically divide by x minus 1/2. But we're going to do it synthetically. So put my 1/2, put my 20, my 12, my -5, and my -3. So bring down the 20. Half of 20 is 10. Add up, we get 22. Half of 22 is 11. We get a 6. Half of 6 is 3. And lo and behold, we get a 0. So the good news is we've got this thing factored. And here is basically your quadratic quotient. So my function at this moment is the factor x minus 1/2 times 20x squared plus 22x and then plus 6. All right, and so there we have that. We basically now have to solve this polynomial back here. And again, it was kind of hard to tell exactly where that's occurring along with my list. It could be, you know, maybe -1/2. So let's try that out. So we're going to divide by x plus 1/2. But remember, I don't want to go back to the original function. If 1/2 is a factor, it's going to be a factor of that guy right there. So let me put the half there, my 20, 22, and 6. So let's see if we get lucky. So bring the 20 down, that's -10, that's 12, -1/2 times -6, we get a 0. So we got it. So our function now, we found two of our zeros, -1/2 and 1/2. But breaking my function down, right, we have x minus 1/2, x plus 1/2, and then right there we have 20x plus 12. And I think we're done. At this stage, if maybe we factor out, I think we can factor out, what, a 4. And I'll bring that out front here. And we're left with 5x plus 3. So what's the other 0? It's coming from there. So 5x plus 3 equals to 0. Subtract 3. We get 5x equals -3. Divide by 5. Our last remaining 0 is -3/5, which actually is on my list. So plus and minus 1/2 we proved, and plus or minus 3/5. Thankfully, everything is rational, right? There's no irrational numbers. And so what's my answer? Well, my zeros are at 1/2, -1/2, and -3/5. All right, and another payoff is we've started to factor the polynomial. If you wanted to, we could have probably pulled a 20 out of there, right? And if we'd have pulled a 20, that would be 20 x minus 1/2, x plus 1/2, and that would have been 3/5, matching our theory, right? X minus c, x minus c, x minus c. So another payoff is we started factoring the polynomial. Graphically, we found its x-intercepts, and we've answered the question, where is its zeros? At 1/2, -1/2, and -3/5. So we got a lot of moving parts, a lot of cool things occurring, but it all basically comes down to that theory. We're synthetically dividing, finding remainder of zeros, and we just keep whittling away at the polynomial till we get to something we can manage and finish off. So last one, and then I'll do some more problems that will seem different, but they're the same thing. So what are the zeros of this function? Well, again, we start with our list of possible rational zeros. So what are our factors of 9, plus or minus 1, plus or minus 3, plus or minus 9? What are my factors of the lead coefficient? Well, just plus or minus 1. So dividing by 1, we basically have these 6 possible answers. Okay, and again, back in my day, I would start there. But what we're going to do is go use our technology. Let me turn this function off, turn this function on, and when I go graph this, oops, my window is, let me zoom out, let me zoom standard here. Zoom standard. So when I zoom out, we can see that we're crossing the x-axis only once, all right, and that crossing seems to be happening really, really close to 1. So it looks like x equals to 1 is our possibility here, all right. I actually don't think I graphed this right, so let me see if I did this right. We have x to the 4th. Oh, there it is. There's my problem. That should be a +8 right there. No wonder why it was giving me something goofy. Second insert and plus. Now let's go graph. So when I go graph this, now that's right. Okay, there we go. So it looks like -1, 2, 3. So it looks like -3 is a culprit, -1 is a culprit, and 1. So let me go ahead and just kind of zoom in on that x-axis. So let's go to -5 to 5 and just kind of take a closer look. So yeah, so -3 looks like it's happening twice. 1 looks like it's -1's happening, and then +1. So from my list, right, it looks like we have x equals -3 with multiplicity 2. It looks like we have x equals to -1 with multiplicity 1, and x equals +1 of multiplicity 1. That's what it looks like. So how do I be sure? Let's start dividing. So let's start with the -3. So if I divide by -3, we get 1, 6, 8, -6, -9. So drop the 1, -3 times 1 is -3, we get a 3. -3 times 3 is -9, adding we get -1. -3 times -1 is 3, we get a -3. A -3 and a -3 is a 9, giving us 0. So at this stage, our function is x plus 3, and then this was a cubic. So x cubed plus 3x squared minus x minus 3. We saw that -3 was multiplicity 2, so that means we have another factor of x plus 3. So again, that must be a factor of that quotient right there. So I'll list its coefficients, 1, 3, -1, -3, and we'll see what happens. So drop the 1, -3 times 1 is -3, we get a 0. That's a 0, -1, -3 is 3, and we get a 0. So my function at this stage, right, is x plus 3 once, x plus 3 twice, and this is a quadratic, right? That's x squared minus 1. And of course we're done there because this is a nice, we have x plus 3 squared, that factors as x minus 1, x plus 1, which matches our other two zeros that we were looking at. So what we've done is not only found the zeros with technology and with theory, but we've also started the process of factoring my polynomial. And back in the day, if I had asked you guys to factor that right there, you'd probably stare at me in the face and wonder, what the heck, how do I do that? And now with the process of division and some zero theory and synthetic division and factoring, there you go. That's how that factors. And then we can clearly see the zeros and all the behavior. So there you have it. So that's putting it all together. I'm going to do another round of problems that will seem a little bit differently, but they're basically the same idea. And I'll see you guys in those next examples coming soon.